Welcome. In this video I'm going to show you how you can perform a Welch t-test using Excel and not using the data analyzer. This is going to be a somewhat longer video because it requires quite some steps. The first thing to do is, actually I'll show you my example data. I have two groups, 1 and 2, and each gave grades, and based on these two I want to determine if there's a difference between the two groups. So the first thing I want are actually the number in each group, so I can use a COUNTIF function for that. The range is going to be column A, and the criteria is going to be this one up here. I can then simply copy paste this or use the autofill handle to do that for me. Then the total is simply the sum of these two, so you can use alt equals as a shortcut for the sum function, and that gives you 41. Then we also need the average per group, so I can use average if for that. And the first thing it needs is the range. That's going to be this one again. The criteria is going to be the 1. And then we want the average of column B in this case. I can again copy paste this down. And the overall mean, why not? We can also put that in, is simply the average of column B. Then we need to determine the square difference between each score and the corresponding category mean. So that's a little bit tricky, but what we're going to do is we're going to open up a set of parentheses. Then we're going to take the score, and then we're going to use an if function that says if this one is actually equal to the first category, and we'll block that using F4, so it puts dollar signs around it. Then it should actually do minus this one, F4. And in all other cases we know that it has to be doing this one. So F4 again, and then we actually close the if function, we close the set of parentheses, and we actually square the result. Note that all of this will actually only work if you actually don't have any missing values and all your categories are in here. You can then just copy paste this down, or in my case I'll simply double click, and as you can see it nicely does all of that. Then we need to sum up the results, but by category again. So what we're going to do is sum if, and then the range is of course A, column A, the criteria is this one, and then we actually want to sum these new results. That was column C, and I can simply copy paste down. Then we actually need to also determine this one, which is simply the variance actually, and that is going to be the sum of those squares divided by, open up a set of parentheses, and then the count minus 1. And I can also copy this down. Then finally the standard error, which is this complicated looking formula, but we have all those values, so we can simply do square root of this one divided by the sample size of that one, plus this one up here, the second category, divided by that sample size. And that gives us 8.7. Then finally the t-value is the difference between the two averages, so this one minus this one between parentheses, divided by that standard error. So far so good. Then we need the degrees of freedom. That's a big scary formula, but we actually have all these values. I'll first do the numerator, which is going to be a set of parentheses, and then we take that variance, and we divide that by the number of items, and we add to that the other variance and divide that by the number of items. Then we close all of this and we square the result. Then here we do the same thing again. We simply take the variance, but that needs to be squared, and then we divide that by, open up a set of parentheses, the number in this category, and that was squared, so that takes care of this part, and then times that G8 minus 1, Then we close all of that. So that takes care of this one. Then we need to add to that the same thing, but now for the second one. So that's going to be this squared divided by, open up another set of parentheses, this one squared times this one minus 1, and we can close everything off. Finally, the degrees of freedom itself is then simply dividing these two by each other, and we can use the t-value and the degrees of freedom to finally figure out the p-value, and that's going to be equals t dist, and then we have to take the absolute value of our t-value, and we can actually then say the degrees of freedom is this one, and we want it two-tailed. So that's about 0.499, so that's above 0.05, so most people would not consider this significant at all, and therefore there's no significant difference between the two averages, which were indeed pretty close. You can also use the slightly newer Excel function t dot dist dot 2t for two-tailed, and then use the same input, the absolute value of the t-value, and we also then need the degrees of freedom, and of course that should give us the exact same result. Well, that was it. I hope you found this video helpful. If so, please subscribe because that really helps out, and thank you for watching.